Hi, this is Ms. Billerbeck, and I'm going to go over section 14.3, direct proportion. So when we have two quantities, x and y, and they vary such that y over x equals a constant, let's make that constant k. Or we can write this, if we multiply each side by x, it ends up being y equals kx. Okay, so if it varies such as this, it is in direct proportion or to be directly proportional. Now there's two things about proportionality. Direct proportionality. One, it has to vary with a constant. Okay, and two, well, actually, when it varies as a constant, it has to go through the origin. And it has to be linear. Okay, so that's very, very, very important that it goes through the origin and it's linear. So those are the two things when we have a direct proportion to be looking for. All right, so let's look at So when we have, there we go. When we have a number table and we have hours designated as a T, so we have 10 hours, 20 hours, 30 hours, 40 hours, and wages in dollars. So for 10 hours, we make $150. 20 hours, we make $300. 30 hours, $450, and 40 hours, $600. So we want to show that this is a direct proportion. So what we're going to do is we're going to put W over T. So W over T, 150 over 10 that's just going to be 15. Okay, 30 over 20, well, that's 15. So 450 over 30 equals 15. And 60 over 40 equals 15. So our K, right here, K, is 15. So the equation we can make is y equals 15x, because we found that our direct proportion, K, equals WT. So if we work 35 hours then, okay, so let's look at what that would be. We'd have Y, I'm sorry, that's a W. Sorry, we're using WTs. And I went and I switched it back. So WT. So if my time is 35 hours, my W is 15 times 35. Okay, so 10 times 15, well, let's just do this using the dry erase calculator. 35 times 15. So we have 5 times 5 is 25, carry a 2, 5 times 3 is 15, plus 2 is 17. Put a little 0 here, and then 1 times 5 is 5, 1 times 3 is 3, and we add it up. We have 5, 12, carry 1, 5. So this is $525. Okay, I need this space for something else, so buy dry erase calculator. Okay, so then what if we make $675? Then what is T? So this one we're going to have $675 for our W, 15T. We want T by itself, So we divide by 15. All right, let's go back to this dry erase calculator. 675 and 15's right here. So how many 15's in this? So 2 and 30, so that's 60's double 30. So that'd be 4. So we have 60. Subtract, we have 75, so that'd be 5. And that gives us 75. So T, let's see, T equals 45 hours. So with almost a little over a week, well, some people 45 hours is a week of work, you make $675. Okay, so if we were to plot this, now that we're done using our dry erase calculator, if we were to plot this, hopefully we're going to see what? What are we going to see when we see the line? If you said it should go through the origin, oh, yes, that'd be right. And it should look like a line. So we have 10 at 150, 20 at 300, 30 at 450, and then this would be way off over here. So we do have a line. Okay, so that we have a linear relationship. Okay, and that's very, 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 very important. How important? Very. Okay. Now, let's look at when two quantities x and y are in direct proportion, then given coordinates x1, y1. Now, these are just names when we have a subscript. Okay, those are names. They're not exponents. They have nothing to do with the value of number. It's a name. It's like Miss Billerbeck. Miss Billerbeck and let's see, Mr. Lee and Shannon and Jacob. Okay, so they're just names, but we're saying x1, y1 because we're math nerds, okay? And these are coordinates, and x2, y2. So when we have coordinates like that, then we can put the coordinate set that belongs to this on the top and the coordinate set that belongs on this on the bottom, and make sure our y's are together here and our x's are together here, and that should be equal. But we have to make sure x2 and y2, because they're in the denominator, they aren't 0, because what happens when you have a 0 in the denominator? It's like dividing by 0. And when we divide by 0, this vortex comes out in the universe and just sucks you away into the undefined regions of space. So we never divide by 0. We don't want that vortex to show up. Okay. So, all right. So we have, for example, 2, n equals the number of chocolates. Big M is the mass of grams, in grams. So we have a direct proportion, M equals K times N, where K is our constant of proportionality. So this is a direct proportion. So then it gives us N1, M1, and N2. Wait a second, we just had this. I think we have to use that formula. So let's look at how we would use that. So we're trying to find M2, so we probably want that on top. So we're going to put M2 over M1 equals, and then that N2 should go with the M2 on top over N1. Hey, wait a second, that's the opposite of this. So are you saying that you could just flip this over and change it around. And then these two couldn't be zero. So what if I did that? What if I said y2 over y1 equals x2 over x1, but now these two can't be zero. Is that true? Can I do that? Yes, I can do that. Okay, I'm just flipping it over. So if this was 2 and that was 2, then this would just be 1/2 equals 1/2. So it's still going to work. We just have to say that these two can't be zero now. Okay, so that's what I did here. I just flipped it over because we're missing M2, and it's easier to have the missing value on top. Okay, so let's fill this in. So we have M2, M1 is 180 grams, and I would suggest following your units with the numbers. N2 is 20, and that was just pieces of chocolate, and 15. Okay, so to get rid of this 180, we would multiply by 180 on both sides. Okay, so that cancels out, and we multiplied by 180 grams, by the way, because I canceled the grams. So that went too. So that way we come up with M2 in grams. So that's why we follow our units. Okay, so these are big numbers. I'm looking at them going, I don't want to use a dry erase calculator. I can do this. I can do it. So I'm going to take a 5 out of here. So 5 times 4 is 20, and 5 times 3 is 15. So I just canceled. And then I know 3 goes into 3 once, and 3 goes into 180 60 times. And look at that. Now I have an easy thing to calculate. Okay, so remember, try not to work too hard. Reduce and make your life easy. So M2 is then 4 times 6 is 24. And then we had a little 0 there, and then grams, because we remember to follow our units. And then we have the answer. Isn't that cool? So if we had 20 pieces, their mass would be 240 grams. Oops, with my cat. All right, so let's do the last example here. All right, here we go. Let me get that so you see it. All right, so example 3, we have a square piece of glass panel, and it follows this rule. The mass equals a constant of proportionality times L squared, which is the side squared, the length of the square. So it's a square, so we know that this side equals that side. Okay, so we want to know what the mass is when the panel is 30 centimeters. So we're going to put this as mass 2 over mass 1 equals, and then we have L2 squared over L1 squared. So we can't forget our squares. That's a big deal. So we have the mass 1 is that. We're going to call this L1. So let's put M2 here, and mass 1 is 1,000 grams. And L2 is 30 squared. L1 is 20 squared. So then what we have is we're going to multiply both sides by 1,000 grams. And that's going to cancel that out. So we have M2. So now we have M2 equals 30 squared is 900, because 3 times 3 is 9, and 2 zeros because we're squaring. And 2 times 2 is 4, and then we're squaring a 10, so that's a 0, 0. And then we have times 1,000 grams. So we followed our units. So that cancels. All right, so now I need to know what 9 divided by 4 is. Okay, so let's do that. We have 4 in, remember top dot goes into the house. So we have 2 here, which gives us an 8. Subtract. We have 1. We drop a 0 down. There are 2 4s in 10, so we have another 8. Subtract 2. Drop another 0 down. So there are 5 4s in 20. That's a 0. We drop. Oh, we don't care. But if we wanted to keep going, we could do that. Okay. So we have 2.250 times 1,000. I'm going to have to clear up my dry erase calculator here. Okay, times 1,000 grams. So that means I'm going to be moving this 3 decimal places because there's 3 zeros. So 1, 2, 3. Okay, so mass 2 equals 250 grams. Okay, so there you have it. However, there is a problem. Yes, I am going to be a math curmudgeon. We have a problem. Your author said this is a direct proportion, and I do not agree. Why? Why would I not agree with your author that this is a direct proportion? Anybody see the problem with the graph? Here, let me show you what the graph for a direct proportion looks like. Maybe you'd see the problem. It is going through an origin. Hey, what's wrong? Why am I being a math curmudgeon? Why do I disagree with the author that this is not a direct proportion? Oh, you said, wait a second, Miss Bilibet, that's not linear. It has to be linear. It's going through the origin, that's okay. But it's not linear. That is correct. You are so smart. Okay, so anyway, this is not a direct proportion, even though it has a constant that is showing the relationship, because there's a square right there on the side. That is not a direct proportion. Okay, you cannot have a square, a cube, a 4, a 5. It has to be a 1 for an exponent or not shown at all. You know, L to the first is just written L. Okay, so it can't have a square to be a direct proportion. All right, has to go through the origin. It has to be linear. All right, so with that, you are ready to do your homework and show your brilliance. Have a wonderful day.